To size a pull box that contains one angled pull and two straight pulls, where all three raceways contain conductors 4 AWG or larger, you will need to follow a step-by-step approach. Firstly, calculate the cross-sectional area CSA of the conductors. For 4 AWG conductors, the cross-sectional area is 410.7 kcmil, which is equivalent to 0.4107 square inches. Secondly, determine the number of conductors in each raceway. For this example, assume there are 3 conductors per raceway. Thirdly, calculate the total cross-sectional area in each raceway. This is done by multiplying the number of conductors by the cross-sectional area per conductor. So, the total cross-sectional area is 3 times 0.4107 square inches, which equals 1.2321 square inches. Fourthly, add 25% for future expansion. This is a common practice to ensure the pull box can accommodate additional conductors if needed in the future. The adjusted total cross-sectional area is 1.2321 square inches times 1.25, which equals 1.5401 square inches. Fifthly, determine the required pull box size. Select a pull box with an internal cross-sectional area greater than or equal to the adjusted total cross-sectional area. For example, if you choose a pull box with the following dimensions, a height of 6 inches and a width of 6 inches, the internal cross-sectional area would be height times width, which is 6 inches times 6 inches equals 36 square inches. This pull box exceeds the required cross-sectional area of 1.5401 square inches. Therefore, it is suitable for the given configuration. To further clarify the process of sizing pull boxes according to the National Electrical Code, NEC, consider additional factors and rules. When dealing with pull boxes or junction boxes housing conductors of 4 AWG or larger, specific rules apply to ensure adequate space for pulling and bending conductors. These rules differ based on whether the pull is straight or involves angles or U-pulls. For straight pulls, according to NEC section 314.28, A1, the length of the pull box should not be less than 8 times the trade diameter of the largest raceway entering the box in a straight pull. This calculation ensures enough space for the conductors to be pulled straight through the box without excessive strain. For example, if the largest raceway entering the box is a 4-inch conduit, the minimum length of the pull box for a straight pull would be 8 times 4 inches, which equals 32 inches. For angle pulls or U-pulls, NEC section 314.28, A2 provides a different set of rules. The distance between each raceway entry inside the box and the opposite wall of the box should not be less than 6 times the trade diameter of the largest raceway. This calculation applies to each raceway entering the box that involves an angle or U-pull. Additionally, the sum of the diameters of all raceways entering one side of the box must be included in the calculation. The derived distance is measured from the raceway entry point to the opposite wall. The minimum pull box dimensions should adhere to the following formula: distance equals 6 times the diameter of the largest raceway plus the sum of the diameters of all other raceways on the same wall. This formula ensures sufficient space for conductors to bend without exceeding their bending radius, preventing damage to the insulation. Also, this facilitates easier pulling and prevents strain on the conductors and connections. When multiple raceways enter the pull box, each with varying sizes, you must consider each raceway separately to determine the minimum dimensions. If a pull box contains both straight pulls and angle pulls, you must satisfy the requirements for both types of pulls. Generally, the more restrictive requirement will govern the overall size of the pull box. Furthermore, the depth of the pull box must be sufficient to accommodate the locknuts and bushings required for each raceway entry, as well as the bending radius of the conductors. The NEC does not specify a minimum depth, but it must be adequate to facilitate proper installation and prevent damage to the conductors. In addition to the NEC requirements, consider practical factors such as the working space around the pull box. Sufficient space should be available for personnel to access and work on the conductors and connections safely. This working space is especially important in industrial or commercial settings where maintenance and modifications are frequent. Pull box material should be suitable for the environment in which it is installed. Options include steel, aluminum, and non-metallic materials. Steel pull boxes are commonly used in general applications, while aluminum pull boxes are preferred in corrosive environments. Non-metallic pull boxes are suitable for damp or wet locations and offer corrosion resistance. Always refer to the latest edition of the NEC and local electrical codes for specific requirements and regulations regarding pull box sizing and installation. Electrical codes may vary by jurisdiction, so compliance with local codes is essential to ensure safety and regulatory compliance. Incorrectly sized pull boxes can lead to several problems, including difficulty pulling conductors, damage to conductor insulation, and increased risk of electrical faults. Proper sizing, on the other hand, ensures easier installation, reduces the risk of damage, and enhances the overall reliability and safety of the electrical system. In summary, sizing a pull box for conductors of 4 AWG or larger involves several steps. Calculate the cross-sectional area of the conductors, determine the number of conductors in each raceway, calculate the total cross-sectional area in each raceway, add 25% for future expansion, and select a pull box with an internal cross-sectional area greater than or equal to the adjusted total cross-sectional area. For straight pulls, the length of the pull box should be at least 8 times the trade diameter of the largest raceway. For angle pulls, the distance to the opposite wall should be at least 6 times the trade diameter of the largest raceway, plus the sum of the diameters of all other raceways in the same wall.